Good morning to one and all. On the behalf of Kekewa College of Agricultural Engineering and Technology, Nasik, I, Professor Shubhangi Gawande, Department of Renewable Energy Engineering, extend a very warm welcome to our today's guest speaker, Dr. Sumit H. Dhavne, sir, Assistant Professor, Department of Chemical Engineering, Maulana Azad National Institute of Technology, Bhopal, and all the students and faculties present over here online. I am very happy to introduce you, sir. Dr. Sumit H. Dhavne, sir, is currently working as a assistant professor at Maulana Azad National Institute of Technology, Department of Chemical Engineering. He did his BE in Chemical Engineering from Shivaji University, Kolhapur, Maharashtra. Sir completed his MTech and PhD in Chemical Engineering from National Institute of Technology, Durgapur, West Bengal. He worked as research associate at HPCL Green Research and Development Center, Bangalore. Also, he worked as production officer at Aarti Drugs Limited, Mumbai. Sir has published 20 research papers in national and international journals and one book chapter. Also, Sir is certified as Outstanding Reviewer by Journal of Energy Conservation and Management, Process Safety and Environmental Protection, Applied Energy, Journal of Environmental Chemical Engineering, etc. Now, I request Dr. Sumit H. Dhavne sir to start presentation on the topic of biodiesel production and utilization. Dr. Sumit H. Dhavne sir.
Yeah. Am I audible?
Yes, sir.
Okay. So I think the presentation is visible to everyone.
Yes, sir.
Okay. Very good morning to all. I thank you very much, Professor Gawande, for such a nice introduction. And I also very humbled to give this talk on a biodiesel production and utilization. So, so I think I will start with covering the basics of biodiesel production, and then as the audience, I think it may be some faculties are also there. So I will try to focus on some advanced researches that is happening in this biodiesel production technology. But first, I will start with the basics. That what is this biodiesel? What are the production technologies that are used in this biodiesel production? And what are the that whatever the resources that we are having, and if you compare the resources with the energy demand in India as well as other countries like China and all, this demand cannot be fulfilled entirely by the fossil fuel. So that's why we have seen in the recent times the industries like Tesla and all are coming with the EV vehicles. Recently, not this year, last year also, one Nobel Prize was granted for innovation in batteries, right? So basically, the research on batteries, hydrogen, and there are various resources which can be treated as a very efficient sources of energy, and that can be considered as a renewable. So that particular area is actually getting explored by various researchers and scientists, so that we can able to develop a source, or we can able to provide a source of energy that can actually replace whatever the conventional sources that we are having. Moreover, with the if we see the means demand and supply, there is a huge amount of a gap existing in between demand and supply. So that's why the rates of this electricity also going up. And in order to, and as we India, everyone must be knowing that as India, we are actually dependent on the fossil fuels mostly, and 80 to 85% of this fossil fuel, or let's say crude oil, we import from the other countries. So when we are importing some crude oil from other countries, our economy actually gets dependent on that particular uh, commodity. And due to that, uh, this development of our economy is not happening, because this fluctuation in the oil prices is always happening on the international market or in the international market. So due to that, there are various issues actually, and our economy is actually controlled, or it is driven by this oil demand. So that's why, in order to minimize the consumption of this fossil fuel, or in order to minimize the import of this fossil fuel, we have to develop a technology. We have to find out resources which are easily available in India, which are easily available in abundant amount, so that we can minimize the import, so that we can help in we can help in sustainable development, as well as we can help in developing our economy. So that is what the basic motivation behind focusing on the area of this renewable energy, and more specifically on biodiesel production. So this area, basically, I have worked on this during my PhD as well, and currently also I am working on the production of biodiesel. Along with, there are various biofuels like bioethanol, biogas, and so we are actually trying to figure out the methods or technology by which we can convert this waste material, whatever the waste that is available in the surrounding. We are trying to convert this waste into useful commodity like energy resource. Okay, so that is what the basic motivation behind focusing on this particular area, and what is the demand, or what is the necessity of studying this particular area. Okay, so I'm going to focus majorly on the biodiesel, and biodiesel, everyone must be aware that it is a vegetable or animal fat based diesel, which actually consisting of a long chain of alkyl esters. So these alkyl esters, basically, when we see the process of biodiesel production, generally alcohol is used as a second reactant, and on the, depending upon the alcohol that is being used, that is whether it is a methanol, ethanol, or propanol, depending on that, this name, that is alkyl group, is added, and that particular ester is called as a alkyl, this methyl, ethyl, or propyl ester. So what is the beauty of this biodiesel? Basically, this biodiesel production, if you see, definitely I'm going to discuss on the production as well. But whatever the property, if you see, this biodiesel is actually, as I already said, it is a renewable. Moreover, it can directly be used in the whatever the existing engines that we are having. Means we don't have to do any modifications in the existing diesel engines. So it can be directly used as a pure fuel, means like a B100. It can be used as a B20, means 20% biodiesel and 80% of a conventional diesel. So it can be used in a blend. It can be used directly in the existing engine without, but definitely if we use raw vegetable oil along with the diesel, it is going to produce a lot many gases, or lot many polluting gases, which are not desirable. So that's why it is always desired to convert this vegetable oil into resource or fuel, which will give eco-friendly properties. Like if you see biodiesel, it can be considered as a renewable, it can be considered as a biodegradable, it can be considered as a eco-friendly. Means whatever the amount of you can see why I'm saying it is eco-friendly, because from this figure you can see that let's say biodiesel plant, or this petrol bunk that we generally having. So whatever the biodiesel that is actually being used in the cars or in the automobile sector, that definitely after combustion of this biodiesel, it generates lot amount of CO2, and this particular CO2 again is absorbed by the process of photosynthesis by the plants that we are actually growing for the generation of its feedstock. So that's why it is generally it is quite a debatable topic, and it is considered as a whatever amount of carbon dioxide is emitted by the combustion of this biodiesel is totally absorbed by the plants that are actually grown for the synthesis of, for the production of their feedstock. So generally it is considered that the null effect or net effect of this carbon dioxide onto the environment is actually zero. So that's why it is quite debatable. Few people may not agree, or few people may agree, because it is actually a debatable topic that whether Is it true that whether whatever amount of CO2 is getting emitted, it is totally get absorbed or not? It is a quite questionable topic, but it is a hypothesis, and it to some extent it is true, because definitely the plants that we generally grow, they need carbon dioxide for the photosynthesis reaction to take place, right? So uh, we have seen the definition of biodiesel and the what are the feedstocks. Now there are various feedstock from which this particular energy source can be produced, like edible vegetable oil. Then second one is the non-edible vegetable oil, waste recycle oil, and animal fats. So these four I have actually pointed out. One more we can add is a microalgae or cyanobacteria that is actually uh, trending in the today's days. So a lot of people are focusing on the uh, extracting oil from the microalgae, but culturing and producing microalgae in the laboratory is quite easy. But we have tested when we do it on a larger scale, it becomes very, very difficult because it, it actually may not grow at the same rate at which we want in the laboratory, because there are severe and harsh conditions are available in the environment or in the atmosphere, which do not favor the growth of this microalgae uh, in the actual conditions. So that is the one difficulty that microalgae is actually facing. However, other resources, if you see, that is edible vegetable oil. So we can say the first generation biodiesel that was produced, it was actually produced from the edible vegetable oil, means whatever the oil that we are eating or we are consuming for the cooking purpose, like soybean, rice bran, and there are many like olive oil and all. But this oil, if you see, what is the main problem is there, that edible vegetable oil after crude oil, if you see the import in India, around 40 to 40%, 40 to 45% of oil or this edible vegetable oil we are importing from other countries like Malaysia and all. They are supplying us palm oil, and we as we are importing this edible vegetable oil, it is also a very important commodity for our agriculture industry. So we have seen that have given the strict norms of produce blending the conventional fuels with the biofuels with the ratio of 20%. However, our PSUs or our Indian refineries are not able to produce that much amount of biofuel. So there is a huge, huge demand, and there is a huge actually problem in the supply of this particular oil. So that's why it is a very important issue, very important topic, and very thrust area of research on which people can focus and develop efficient technology so that we can get a biodiesel in a large amount. Yeah. So the third, as I was telling, that these three PSUs are actually planning to commission a plant, and they are trying to convert this waste recycled oil by diesel. And the fourth one is the animal fats, but definitely we do not have abundant amount of animal fats available, and so it can be treated as a source for the production of biodiesel. But definitely when we are choosing a source, we should have different parameters on the basis of which we are going to select mm, which source we are actually taking as a feedstock. So that parameter I will discuss. Yeah. So what are the crops? As I already told you that this edible vegetable oil and non-edible vegetable oil. So edible, basically, you can see, I don't know. Yeah, there are few are there, like soybean oil, coconut, and olive oil. These are generally considered as a edible oil, and these oils are actually uh, not actually preferred or not recommended to be used as a feedstock for the production of biodiesel. As I said, it causes a serious threat to the food supply. So that's why the focus is actually towards, or the focus has shifted towards utilization of some non-edible resources. So in the non-edible resources, definitely algae is a kind of a different uh, resource, and you can see it is one of the resource, that is algae. And animal fat, as I already said, the coconut. One interesting is there, that is a chocolate. So many must be wondering that how this chocolate can be used as a resource for the production of biodiesel. But the thing is that I hope many people actually very recently the research have been published on the utilization of this particular thing in 2020 itself. And as we all know that the production of a chocolate is means it is means the resources that is actually required for the production of the chocolate, it is coming from the African countries. And the major producing or major producer of this particular tree, that is actually that is, I guess, I'm not able to recall the name of that plant, but that plant is actually mostly grown in Ghana. It is an African country, and the project is actually sponsored by Nottingham University from UK, and they are working on the production of the biodiesel from the oils that are actually getting generated during the production of chocolate. So the plants that is being used for the production of chocolate, they are also having a waste material which can have a sufficient amount of oil, and that can get converted into biodiesel. So this is what the so similarly, there are many feedstock that are available in our surrounding, and it is our responsibility. The first responsibility is to find out what are the feedstock that can be actually considered, and what are the parameters that first should be looked into in order to select that feedstock. So that we are going to discuss that how we can select these biofuel trees. So purposely, I have shown the picture of your Jatropha because it was very famous in India, and not only in India, all over the world. And that Jatropha can act as a very prominent source of or prominent feedstock for the production of biodiesel. It was that hype was created, and in India, or Indian Railway they have started utilizing this biodiesel in various railway engines, and they used to run one express also, that is which runs from Howrah to Chennai, that is Coromandel Express, and it used to run on a biodiesel. And again, I think near Pune, this Indian Railway, they have procured a huge amount of land, and they've tried to uh, plant these Jatropha trees, but this project got failed. And this the main reason for uh, main reason for failure of this particular project was actually overlooking the points that are actually highlighted over here. So it's very important whenever we are going to select, and whenever there is a need whenever it is said that we are going to select this particular technology, and we are going to select this particular feedstock. First of all, we should know whether we are having that particular feedstock in an abundant amount or not. So if we plant this Jatropha on a large scale, uh, in a large land as well, definitely it is going to take a huge amount of land, and it can give the required amount of feedstock, but definitely it will not going to give the amount of feedstock which can fulfill the the gap that we are having between demand and supply. So that's why. And the second point that is actually very important is that the growth period for the Jatropha tree is very high. So when the growth timing is high, so continuously this particular tree cannot supply the seeds. And as it cannot supply the seeds continuously, the oil extraction is not possible. And when the oil extraction is not possible continuously, it is definitely uh, going to create a shortage of feedstock to the production plants, and that's why this particular project got failed. But what are the other things that can be looked into? Means for selection of any feedstock, that is high yield of oil. So whenever we are taking a seed, first of all, we have to identify how much amount of oil is present in that particular seed or any feedstock. So how much amount of oil is present, that percentage, first of all, uh, we have to identify the least risk of failure. So definitely the failure risk that we have to identify. And as I said already, that what are the parameters on the basis of which this Jatropha means biodiesel production from the Jatropha has been actually stopped, and it is not actually being practiced now. Okay. So third one is the least cultivation input. So definitely we do not have to provide or there should not be a necessity that we provide lot amount of inputs or nutrients or fertilizers to the plant, and then only it can give sufficient amount of feedstock. So that should not be the case, because if we try to give lot of amount of inputs into the growth of a plant, then definitely, because when we see the biodiesel production, the maximum cost is bared by the uh, cost of a feedstock. So it is around 70 to 75%. So there is no any scope that we can compromise with this particular cost. So that's why with the minimal expenses of the resources, we should get whatever the feedstock that we want. So that's why it is generally considered as whatever the waste material that we are having, it should be treated as a feedstock for the biodiesel production instead of separately growing or cultivating any plants or trees. Okay. So the fourth factor is the high acceptability of the farmers. So definitely, if we can able to convince the farmers to cultivate or to uh, take uh, take this particular plants or energy crops in their fields, then in that case, definitely we can able to produce a lot amount of uh, feedstock. So that is the other factor that have to be uh, focused on. Then suitability of oil for diesel. So definitely, uh, uh, there are many factors. There are fatty acid profile composition needs to be derived. What are the fatty acids that are present over there in the means that composition needs to be identified, and on the basis of that, we have to see that whether this particular biodiesel whether this feedstock can have that potential which can be converted into efficient or prominent biodiesel. Okay. So there are other factors that are available. Each I will not going to discuss, but they are very common. These factors are very common, and if we look into that, this is means if we apply our common sense, we can say that definitely these are the factors. First, we have to consider before selecting any feedstock. So before claiming that I am going to develop a technology for the production of a biodiesel, first of all, the main important factor which is playing a role is the feedstock, and that feedstock needs to be selected very accurately. Okay. Okay, so this was all about the feedstock, and now we will move on to the production method. So there are four production methods are actually used, and one is the blending. Means the blending, the very first, like when the diesel engines were uh, invented by Rudolf Diesel. That time, what he did, he actually tested this vegetable oil as a fuel in the diesel engine also. So the direct blending means we can directly blend this vegetable oil with the conventional diesel, and it can be used as a fuel in the diesel engine. But there are various issues that, like previously also I said, that it emit various gases which are not actually desirable. So definitely you can see the carbon deposits increase, smoke, CO and SC emissions will be increased. So these are various issues, and actually what happens, this conventional diesel and vegetable oil is not actually miscible. So due to that, a two layer formation happens, and uh, due to that, proper combustion or atomization of the oil will not happen, and that leads to a problem of combustion and all. So that is not a preferred method. That's why uh, direct blending of vegetable oil with the diesel is not actually preferred. The second one is the pyrolysis. So definitely, when the pyrolysis is done at in the inert atmosphere at very high temperature, generally nowadays the people are trying to focus on the catalytic pyrolysis, where they are converting the feedstock into or bio oil. Generally, we say, so people try to use this bio oil as a fuel, but this bio oil is also having various uh, means oxygen content and all, and the impurities are very high in the biodiesel, and the reaction which actually happens means when the desired product, uh, let's say our desired product is a bio oil, but along with that, this particular process gives many other impurities and side products which actually are not desirable in the reaction. So that's why it is. And one more thing, whenever I say pyrolysis, it is actually uh, whenever I'm saying pyrolysis, it is actually a energy intensive process. So definitely a lot of amount of energy is actually incurred in the production of this particular uh, particular method. So that's why it is generally considered as an expensive step. And the third one is the micro emulsion method, where actually various surfactants are used in order to create the emulsion. And this vegetable oil or the feedstock, whatever we are using, is actually mixed with the different alcohol along with the surfactant in order to increase because if you see or if you conduct the experiment in the laboratory, uh, if you see this alcohol, that is methanol or let's say ethanol and oil, they are partially miscible. They are not completely miscible. So when there is a complete, when there is means there is a separation factor is always existing between a layer of methanol and oil. So due to that, what happens? The complete mixing is not possible without providing stirring or without providing agitation. So definitely there is an interface exists between the oil and alcohol, and in order to avoid that, some surfactants are added. But whatever the biodiesel is actually getting produced, it actually leads to an incomplete combustion because uh, it have this means after production, it generally have some amount of impurities that is present over there, and it becomes difficult to separate the biodiesel that is getting produced through this method. And the final stage, which is widely accepted and which is generally used on the larger scale all over the world, that is transesterification. So transesterification, why it is widely accepted? Because it is a cost effective method and give very, very high conversion efficiency. So we have tested almost 95 to 96% of conversion can be achieved through the transesterification process. Moreover, if we compare the if we compare the properties like fuel properties of this vegetable oil and biodiesel, we can see the appreciable change or change in the properties of a biodiesel. So that's why it is said that it can improve the fuel characteristics. And one more very important advantage of this particular process is that it can produce glycerol as a byproduct. So this glycerol is having a lot of uses. It can be used in a medicinal purpose. It can be used in a cosmetics. We can convert this glycerol to glycerol carbonate. So there are different products that can be produced from this crude glycerol. So definitely, when we see the economics of the process, our main aim is to produce a biodiesel. However, along with the biodiesel, we are getting a glycerol, and that glycerol can be used as a very important commodity or feedstock for the production of several other compounds or several other chemicals. And due to that, the cost of biodiesel is very high compared to ethanol. It can be several parameters on the basis of which this alcohol is actually used. Although as methanol is the means it is the shortest alcohol we are having, and if we go on with the production of biodiesel from ethanol and propanol, as the cost of ethanol and propanol is very high as compared to the methanol, so that's why methanol is preferred over ethanol and propanol. Moreover, although methanol is corrosive as compared to ethanol and propanol, the rate of reaction, if you see the transesterification reaction, it is always said that along with the transesterification, the side reactions are happening, and that side reactions are saponification. So if we use the ethanol and propanol, the rate of saponification reaction as compared to the rate of transesterification reaction is always higher. So that's why methanol is preferred as compared to ethanol and propanol. So if you see the reaction, this triglyceride is reacting with the methanol, and generally stoichiometrically, if we say the 3 moles of methanol reacts, or the 3 moles of alcohol is react with the triglyceride in the presence of catalyst, definitely, and it is giving a product that is biodiesel plus glycerol. Now, what is the main important thing here is that the stoichiometrically we need 3 moles of alcohol for the production of biodiesel, as we are getting 3 moles of biodiesel and 1 mole of glycerol. But if you see carefully, this is basically oral reaction, and we have to see into one by one stage. There are 3 stages of reaction, and then from that, this oral reaction can be derived. Okay. So in practice or in actual, you can see the reaction is reversible in nature. So whenever the reaction is reversible in nature, what happens with the progress of the reaction? There is a possibility that whatever the products that we are going to get, those products may again get converted to reactant. So that's why the desired yield of a product, or whatever the yield that we have desired, is not getting. So in order to achieve that particular yield, or in order to achieve that particular conversion, always there should be a there should always be a method, or there should our approach to shift the equilibrium of that particular reaction on the product side. Means we can able to maximize the production of our desired product. So how to do that? In order to do that, the concentration of this particular reactant, because this is our limiting reactant, and this is our we can say solvent or a second reactant. So we can use this particular reactant in an abundant amount, so that the equilibrium of this particular reaction can be derived on the forward side, means on the product side, so that the product should not get converted back to the reactant. So that's why in although it is having a stoichiometric ratio of 3:1, means 3 moles of alcohol to 1 mole of triglyceride, generally in practice the ratio is taken as higher, like 6:1, 9:1, and 12:1. That I will show you the example that how this ratio is actually affects. Okay, so this is the simple reaction by which this production of biodiesel is carried out, and the catalyst that is generally used. There are three catalysts. One is the acid catalyst. One is the base catalyst, and third one is the enzyme catalyst. So that we will discuss in a detailed manner that how this classification is actually done. So as I said, catalyst, you can see on the basis of catalysis, means the type of catalysis, as we are saying, means homogeneous and heterogeneous. I hope I hope it is clear to everyone that's what is homogeneous catalysis, what is heterogeneous catalysis. But in simplified manner, I would like to explain. uh, as we are having a oil in a, let's say oil in a liquid state, we are having alcohol in a liquid state, and we are adding a catalyst into that, that is a solid. So then it becomes heterogeneous, because there exist two phases. One is liquid and one is solid. And if the catalyst is also in a liquid phase, then definitely it will be a homogeneous catalysis. So in previously or the conventional transesterification processes or conventional plants that we are having in India, which are actually producing this biodiesel, they used to use this homogeneous catalysis process, because the rate of reactions are very high, and the homogeneous catalyst like potassium hydroxide, sodium hydroxide, sulfuric acid, this can be used as a catalyst or homogeneous catalyst. However, this particular active species or chemical active species, if I say, that can be impregnated onto some solid support and can be converted into heterogeneous catalyst. So that's why the question comes as a heterogeneous catalysis. And third one is the biocatalysis. And in the biocatalysis, mainly it is enzyme-based catalysis. So generally, the enzyme that is being used is a lipase. So this free lipase can be used as a enzyme as a catalyst for the biodiesel. So I'll explain what are the merits and demerits of each type of this catalysis. But very shortly, if we see the classification, homogeneous, as I already said, acid and base. So in acid, H2SO4. In base, we can use KOH. We can use sodium hydroxide. We can use methoxides. So there are different compounds are available which can be used as a catalyst. In acid, uh, generally we use as a H2SO4. Okay. And in a heterogeneous catalyst, definitely base heterogeneous, acid heterogeneous, ion exchange reagents. And in the base heterogeneous, you can see the classification. There are various classifications are there, like waste material based catalyst. So we generally focus in our lab, uh, we generally focus on the production of this particular category, that is waste material based catalyst. So we generally take various biomasses and various waste material, and we convert that waste material to some useful commodity, like we extract the oil from them, and we convert that particular biomass or particular waste into a catalyst. So that is our strategy on focusing on to waste minimization as well as production of some energy resource. So we focus majorly on this waste material based catalyst. Second, boron group based catalyst, transition metal oxide. So definitely there are many like if you see the periodic table, there are many metals, there are many alkali or alkaline metals as well can be used as a very good catalyst. So that's why it depends what kind of a catalyst that we are going to need, and depending on that, we have to select various amount of a catalyst. Various type of catalyst that can be produced. So if you see the comparison, now definitely when we have see the classification, we are seeing that it is acid catalysis, base catalysis, enzyme catalysis. So definitely the question will come that among which route should be selected, because definitely that is the that will create a confusion. So that's why I have tried out. I have tried to point out the merits and demerits of each process. Means after that, we can at least able to understand or at least able to analyze which process will be the best. Okay. So if we go on to the chemical process, in the chemical process, generally the catalyst that is used is acid or base. So base catalyst reactions are sensitive to water, definitely. So if the water present in the feedstock, means oil that we have taken for the production of biodiesel, if it is if it contains water, then definitely it is sensitive to then the base catalyst like KOH and NOH. Those are very sensitive to water, and that's why the rate of saponification increases, and we are not going to get the product that is a biodiesel. Okay. The second is the product and glycerol separation is complex and incurs maximum cost. So along with the feedstock, the next problem in the biodiesel production is the product separation. So after the production of a biodiesel, uh, it produces glycerol as a byproduct. And as we are using higher amount of alcohol to oil ratio, it generally creates a problem in separation of this glycerol and biodiesel. And due to that, we have to incur a lot of cost. We have to give lot amount of cost in product purification and product first the separation and then the purification. And because there are stringent norms which are given by the various agencies like ASTM, like BS or Bharat standards, we are having according to BS6. If we see, the glycerol content should be means the parameters for each and every uh, ingredients which should be there in the biodiesel is actually fixed, and we cannot cross that particular limits. So in order to get that particular limits, a lot of energy or lot amount of uh, lot of means lot of cost is actually incurred. Okay. And the reaction must be carried out above 50 degrees Celsius. So definitely if we see the effect of temperature on the reaction, the rate of reaction, if we carry out the reaction at below 50 degrees Celsius, the rate of reaction is very low, and definitely it will take a lot amount of time to achieve the equilibrium. So that's why the temperature should be little bit higher. uh, as I said here, the soap formation leads to decrease in biodiesel yield. So definitely there is always possibility that there will be a formation of soap, which is not desired, and it produces a lot of wastewater, because after the production of a biodiesel, the next stage is washing of this biodiesel layer. So this washing is generally done by means of water, and when the washing is done, this water contains a lot of it may contain some amount of impurities like, or it may also contain some amount of leached catalyst like acid or base. So definitely this treatment of this wastewater which is generated from the biodiesel production plant needs to be done. So it requires additional cost for the this purification or treatment of this water. Okay. However, if you compare all this thing with the enzymatic process, uh, it is insensitive to water. So definitely if the feedstock we are having, it contains a lot of amount of water, then also no problem, we can go ahead with the enzymatic process. The biodiesel yield is highly comparable with the chemical processes. So around 90 to 90%, 90 to 95% even yield can be achieved. And the recovery of this glycerol and this biodiesel is very easy. The reaction can be carried out at very low temperature, like uh, as we have worked on it, and the maximum conversion or maximum yield we generally get around 37 degrees Celsius. So 37 to 35 to 40 degrees Celsius, within that temperature range, maximum biodiesel yield can be achieved. So you can imagine the difference in the temperature. So definitely we do not have to give higher amount of energy as compared to the chemical processes. And the last one is low environmental impact, because we are not getting any wastewater which is generated from this particular process, and whatever biodiesel that is actually getting produced through this process is very pure, and qualitatively it is uh, very good as compared to the biodiesel which is getting produced from the chemical processes. So on this basis, I hope it is clear that which is having advantages, which is having disadvantages. But one more very important thing that I want to mention is that the rate of reaction in enzymatic process is always low. Okay. So although it is having many advantages or merits over chemical process, uh, the rate is low. So that's why the amount, the time that is actually required for achieving the equilibrium conversion, it is very high. Means it takes around 5 hours to 10 hours or 15 hours. It depends upon the what kind of a catalyst that has been developed. However, in the chemical process, the maximum time that is required for base catalyzed reaction is around 1 hour. However, in case of acid catalysis, it is quite higher. So that we can see now we have identified the chemical process and enzymatic process. Now, if you see the chemical process, there are two catalysts. One is the acid catalysis, and second one is the base catalysis. So among which now which catalysis route should be considered? Now, in the acid catalysis, if you see, the rate of reactions are very, very slow. However, if you see in the base catalysis, the rate of reactions are almost 4,000 times faster than the acid catalysis reaction. So if our main aim is to produce biodiesel at very faster rate, then we can go for base catalysis. But in that case, we should have a feedstock means which do not contain water or a moisture. Okay, because it is highly sensitive to the water. It is highly sensitive to the FFA, free fatty acids. Okay. So when the free fatty acid content in the vegetable oil or the feedstock is more than 2%, then in that case, this base catalysis process is actually not suitable because it leads to formation of soap. Okay. So that's why it is always preferable method when there is a feedstock which is available is having a FFA value less than 2%, and it is not having any moisture present in it. Okay. So what is the basic idea is that we need to pre-treat the feedstock for the base catalysis process. However, in the acid catalysis, we can take any feedstock and can convert it into biodiesel. However, the thing is the rate of reaction is very high since it takes a lot of time. The temperature and the alcohol to oil ratio, I means um, whatever the parameters that are critical in this particular process are actually means the expenses are higher as compared to the base catalysis, and the catalyst is actually corrosive. So definitely we are using sulfuric acid. So sulfuric acid is highly corrosive. So whenever we are designing any reactor or setup for the production of this particular uh, acid catalyzed process, it becomes corrosive. So accordingly, the material should be selected. Sorry. So if we are having a feedstock which are very, very means impure and which are very, if I can say, they're very cheaper and very impure. In that case, we can go for acid catalysis. But if we are having a feedstock which are which are uh, which are having very low value of FFA content, then that can be converted by means of a base catalysis. So this is how this process selection is actually done on the basis of feedstock, basically. Now, the types of catalysis, as I already said, this conventional industries or conventional Indian as well as foreign industries, they are running or they are producing this biodiesel on the concept of this homogeneous catalysis, because the rate of reactions are very, very high as compared to the heterogeneous catalysis. But heterogeneous, why there is a problem? Because the major problem and always the problem of with the biodiesel is that cost. Okay, and cost is majorly incurred by the feedstock, and we can't do much with the feedstock because feedstock cost will remain the same, and whatever the remaining 20 to 20 30% cost is there, that is the process or manufacturing cost, and that particular cost is actually coming from the catalysis part. Okay, and why? Because when the biodiesel is getting produced from the base homogeneous process, what happens? Definitely we will get a higher rate of reaction, definitely we will get a higher conversions, but the problem is that catalyst gets consumed during the reaction, and the separation of the catalyst becomes very, very difficult, and due to that this catalyst cannot be reused, and this as this cannot be recycled and it cannot be reused, and due to that in the next batch or in the next cycle we have to add fresh catalyst, and due to that the cost of the entire process is actually getting increased, and that's why the production cost of a biodiesel is also very, very high. So in order to minimize that cost, there comes a concept of heterogeneous catalysis. Why we cannot impregnate this homogeneous kind of a catalyst onto the solid supports or some solid material, and then can be used as a catalyst in a biodiesel production process. So the advantages are it can be reused, it can be operated continuously. Definitely, when there is a homogeneous catalyst, it cannot be operated continuously. So the production, that is the throughput that we are getting, means amount of oil that can be produced per day or per year is less as compared to the heterogeneous catalysis. Okay, the product can be easily separated from the catalyst, definitely, and this catalyst as well as this catalyst is also separated very easily, can be recycled, can be regenerated, and can be reused. So that's why what happens if the catalyst is having a very good activity in reuse,
let's say if in the first cycle we have added 10 kg of a catalyst, and it is giving a conversion of around 95%. And after completion of that particular reaction, I'm talking about the batch process, not about continuous process. And after taking out the catalyst, and if you add again that catalyst in the second batch, and what happens if that particular catalyst is giving a activity of around or conversion of around 94 point something, which is very close to the 95%, means definitely there will be a decrease in the activity of the catalyst, but that particular catalyst can be used several times, and it depends on the that on that particular parameter. The cost of that particular process depends. So we have tried to develop a catalyst, and we have seen that catalyst can be used or reused like around 5 to 7 times very effectively, with the decrease in conversion of around 1 to 2%. So that is acceptable when we generally do the production on the larger scale. Okay. So this is the major point is the production cost is relatively lower in the heterogeneous catalysis. So whenever there is a point of minimizing the production cost or cost of a biodiesel, we have, or as a chemist or as a chemical engineers or engineers, we generally have only one option, and that we can focus on to development of a catalyst, or or intensifying or intensification of the existing process. Okay. So that's why we are focusing mainly onto this, because the development of crops and all, it is a part of or it is a part of research, and other people have to focus on that, that how we can increase the oil yield of any plant, and how we can increase, or means the plant should have a lower uh, time of a growth rate, and it can yield maximum amount of oil. Okay. So that is the area of some other people. Okay. Okay. So this is what about the catalyst and all production methods that we have discussed. uh, what are the critical parameters that are involved in the biodiesel production process? So whenever we are going to start with the experiments on biodiesel production, we need to focus on the reaction temperature, reaction time, alcohol to oil ratio, agitation or stirring speed, and catalyst loading. So what we exactly mean by that? So, and what is the significance of each parameter? So I'm going to explain. See, the reaction temperature definitely, as I said, with increase in temperature, means if we go on increasing the temperature, the rate of reaction increases. Okay. And as the rate of reaction increases, we get a maximum amount of conversion in very less amount of time. Okay. So that's why the reaction temperature is a very critical parameter. And if we go on increasing the temperature, definitely the rate of reaction will increase, but we have to provide that amount of heat or that amount of extra energy, and definitely that will not be energy efficient process. So that's why optimization of the reaction temperature is very, very important. Second one is the reaction time. So definitely time is the critical parameter. And if the time is optimized, and if you can get the equilibrium conversion within a lesser amount of time, then what will happen? We do not have to continuously supply the utilities like stirring, like mm, condensation and all to the biodiesel production unit. So that's why this reaction time optimization is very important. Third one is the alcohol to oil ratio. Although the biodiesel that is getting produced, we are recovering the alcohol from the biodiesel. Means, as I said, generally the stoichiometric ratio is maintained very, very high as compared to the desired ratio. So that's why there is excess amount of alcohol is present always, and that alcohol can be recycled by distillation process. So its optimization becomes complicated, because if we provide lesser amount of alcohol, then definitely the reaction will be shifted towards means it will follow a backward reaction. And if we use higher amount of alcohol than the desired, definitely the cost will increase. Along with that, it creates problems or it creates difficulties in separation of glycerol and biodiesel. Okay. So that is the main reason that the alcohol and oil ratio should be optimized. The fourth one is the agitation or stirring speed. So as I already said, this oil and alcohol are partially miscible. They are not completely miscible. So definitely some interface exists in between them, and due to that, some mass transfer limitations are always existing between oil and uh, alcohol. So as these are the two major reactants, there should not be any resistance in between them. And in order to break that resistance, we need to give some agitation. And as the oil is viscous in nature, generally the feedstock is viscous in nature, so we need to give agitation so that all the resistances which is offered by the mass transfer should be eliminated. Okay, so that is the role of agitation speed or stirring speed. And the final is the catalyst loading. So definitely, I hope everyone is aware that what is the catalyst. Catalyst is any material which actually enhances the rate of reaction. So let's say now we need some amount of energy for the conversion of A to B. If we use the catalyst in that particular process, the energy gets drastically reduced, and due to that, this A to B conversion can be achieved very efficiently. Okay, so that's why the catalyst loading means how much amount of catalyst needs to be added. It's very very important, and that's why it should be optimized. Okay, so these are the critical parameters, and very shortly I'm going to explain you one study that we have conducted in our laboratory. That is the biodiesel production we have done from the rubber seed oil using biomass derived carbon based catalyst. Okay, so in the feedstock part, as I already told you that we are actually focusing on the production of catalyst by using some waste resources. So waste resource that we have collected for our study was Delonix regia. It is a scientific name. It is generally called as flamboyant pods, or and we call it gulmohar in Marathi. So that gulmohar tree. So the pods which are actually the waste pods you might have seen, these pods generally fell down during summer and all. So these pods are actually waste material, and that can be used as a precursor for the production of some useful commodity. And we try to use that as a precursor for the production of catalyst. So we have prepared a catalyst from this waste of flamboyant pods. Why? Because it is available. You might have seen it is available in almost every part of India. So it is abundantly available. It is a waste, and it can be easily converted to any like a carbon catalyst. So we have done the proximate analysis, thermogravimetric analysis. I hope you must be aware that why it is required to do the proximate analysis, because from the proximate analysis, we get to know that how much amount of carbon is there. Because when we are selecting any biomass and when we are converting into some carbonaceous material, we should know that how much amount of carbon that we can get from this particular biomass. Because the problem with the biomass is that it contains a lot of volatile matters. Okay, volatile matter means when we burn it, it will get means it contains some minerals, so it will get vaporized and it will be lost. So we cannot recover that. Okay, so due to that, it is always necessary to calculate how much amount of carbon can be achieved from that particular biomass. So that's why we have done the proximate analysis. And second is the thermogravimetric analysis. So depending on the thermogravimetric metric analysis, what actually is derived. Suppose let's say, as I said, when I'm converting this biomass to carbon, so we need to burn it. Okay, so but at what temperature we need to burn? That is the important parameter, because when we do it on a large scale in the industry, we should know that at what temperature we should carry out this particular process. So that's why in order to achieve that exact temperature, we need to do the thermogravimetric analysis, and there we check that along with the temperature, how the mass loss is actually getting reduced, and the temperature at which it gets constant, we consider that particular temperature as the carbonization or burning temperature. Okay, so this particular precursor, we have done the proximate analysis. You can see over here, the fixed carbon content was around 35%, volatile matter is around 53%, moisture was around 7, and ash content is around 4. Okay, so from this particular data, we can say that 35% of carbon can be achieved from this biomass. So it's pretty good, because there are biomasses available which gives very less amount of carbon, around 20, 30. So 35% comparably very, very high. And the thermogravimetric analysis, as I said, so this is the if we see the x-axis, the temperature, and the mass loss on the y-axis. If we see this red color graph, the mass loss after actually 500 degrees Celsius gets more or less constant, and that's why it was considered. So you can see over here, it is around 0.3. So it is around 0.31. When we done the analysis with the thermogravimetric instrument, it is giving around the carbon yield of 0.31, means 31%. And we have seen from the approximate analysis, it is 35%. So it is more or less similar, because it is instrumental method. This proximate analysis is done manually in the oven and furnaces on the basis of masses. So that's why there may be some difference, and that difference is actually acceptable. Okay, so the feedstock that we have chosen for the production of biodiesel is a rubber tree seeds. So white rubber tree seeds, that, as I already told you, the parameters and how we have how we have chosen this particular feedstock on the basis of that particular parameter. First parameter and very important parameter is that it should be a waste. That is our main purpose, that it should be a waste. Now, what yeah. So what we generally do with the rubber trees are mainly cultivated for the use of its latex, we know, and that latex can be converted, that can be used as a natural rubber, that can be converted to synthetic rubber. But what we do with the rubber seeds, or seeds which are coming out, so a lot of amount of seeds is actually uh, coming out as a waste, and that waste is no one has, means it is actually uh, not yet noticed, not yet got noticed. So when it was estimated what is the percentage of rubber, means oil seed is there, sorry, oil content is there in the rubber seed, it was around 40 to 50%. So that is quite high. Okay. And the third thing, that is our main important parameter, is that it should be available in the abundant amount. Okay. First, it should be a waste. Second, it should have a higher oil yield. And third, it should be available in the abundant amount. Now, if we see the rubber plantation all over the world, India stand among the top 10 countries in the world which are producing this, which are having a rubber tree plantation. Okay. So that's why, if it was also estimated that around 5,000 tons per annum of oil can be produced from these rubber seeds. So one more thing, we are having seeds which are waste, which is having a oil content of 40 to 50%, and it can give such amount of feedstock, which is very, very high. So that's why it can be used as a feedstock. So that's why we have selected it as a feedstock. And definitely, we have chosen it as a good resource for the conversion of its conversion to biodiesel. Okay. So I'll not going to focus much on this catalyst preparation. It is actually, it's not a, it is kind of a chemical and chemistry perspective. So I'll not focus on that. So generally, when the catalyst that is prepared, this is what, through the images I am going to show you. This is the biomass that we have carbonized. So we have got this particular kind of a biomass. Actually, we have activated it with the steam. So it is highly porous biomass we have got, and then we have impregnated with the iron. So iron we have used, and that iron is impregnated onto the surface, and it was acting as a catalyst. So you can see the difference after impregnation. These pores got blocked, and we can clearly see that the iron got successfully impregnated onto the surface of the carbon that we have produced from the lambine pods. Okay. So what is the production process? So as I already told you, the transesterification. So here you can see the flambine pods that we have selected, and we have developed the catalyst from these flambine pods. So in the transesterification process, we have given a methanol. Now here you can see this rubber seed oil. It is also called as Hevia brasiliensis oil. So this oil, first of all, it is characterized in order to estimate what is the FFA value or acid value. And if it is less than 2%, then it is given to the transesterification. If it is higher than 2%, it is given to the esterification. So what happens in the esterification? Acid catalysis. In the transesterification, base catalysis. Okay. So the catalyst in this particular process, we had basically this rubber seed oil having a, means it was pre-treated, so the FFA content was less than 2%. So we directly went for a transesterification process, and the catalyst was added over here because it was a base catalyst. It was a metal doped catalyst. So that catalyst was added, and the transesterification reaction was carried out for the parameters I will show you. And after carrying out the reaction, we get, let's say we have carried out the reaction for 1 hour. After completion of the reaction, we need to quench the reaction very immediately, so that further conversion should not happen. So the reaction is quenched. And what is the reaction mixture that we have got? We have given to the distillation unit, and in the distillation, the excess methanol that was there was actually separated. And after separation of this excess methanol, the remaining mixture, it contains FAME, because in the transesterification, we are getting esters, that is fatty acid methyl esters. So those FAMEs are there along with the glycerol. So it is given to the separation, like this, you can say the separating funnel. So when we given to the separating funnel, we clearly, if we keep it for some time, so via the density difference, the two layer clearly observed. So you can see in this image, this photograph is actually taken in our laboratory. So you can see the two layer are clearly separated. On the topmost layer is the biodiesel, that is the ester, and the bottom layer is the glycerol, that is the byproduct that we are getting from the reaction. So this is how the products can be clearly separated if you carry out the reaction at the optimized or efficient conditions. So for conducting this particular experiment or this study, we have selected, as I already told you, the reaction temperature, temperature, ratio, agitation speed, and catalyst loading. These are the very, very important parameters. And we have, as I told you, that the temperature should be more than 50 degrees Celsius. So we have selected the temperature 50, 55, 60. You might be wondering that why I have not gone for the higher temperature that is above 60. That I will tell you in the effect of temperature. Okay, so generally I'm not going to explain about the optimization, how this optimization is done, and what are the different methodologies. There are different techniques that are available for the optimization of this particular entire study. So we have done the optimization study by following some Taguchi method. It is called as orthogonal array approach, and by that we have designed the experiments, and we have carried out the experiments and understood what is the yield that we are getting at that particular set of reaction conditions. And here you can see the maximum yield was around 97%. So here we got around 97% of yield, and this is not I'm going to explain. Okay, so yeah, so the important parameters that are there, that is the effect of temperature. If I see, you can see here the yield is actually getting increases with increasing temperature. So when the temperature was increased from 50 to 55 and to 60, the yield is continuously getting increasing. Now some might say that if we increase the temperature beyond 60, the yield definitely will get increased if is if you follow this, if we follow this trend. But this is not the actual case. Why? Because we are using methanol as a reactant, the reactant in this particular process, and methanol is having a boiling point of around 64.3 degrees Celsius. Okay, so if you go on increasing the temperature beyond 60 degrees Celsius, what happens? This methanol is actually getting evaporated, and if the evaporative losses becomes prominent, the ratio of methanol and the oil becomes means it starts getting decreasing. And due to that, due to the lower ratio of or lower molar ratio of methanol to alcohol, the yield may get hampered because the reaction may get transferred in the backward reaction, or it may follow the backward reaction. So that's why the temperature selection is very, very important. So that's why maximum yield was around 90 to 92% is around was getting at around 60 degrees Celsius. Okay, so the agitation speed, again, the agitation speed is actually playing a critical role, because here we have used a solid catalyst, and there is a liquid that is oil that we are having, rubber seed. It is a viscous oil. We are having alcohol that is methanol. And when there is a mixture of, as there is a partial miscibility problem or separation factor problem is there in between methanol and oil, uh, we need to provide some agitation speed. And as we are having a solid catalyst, so the diffusion of this liquid reactant to the solid catalyst is actually acting as a resistance. So in order to overcome that resistance, we need to provide extra agitation, and that is generally called as a removal of a barriers like external mass transfer resistances. So like we all know that when we add a sugar in a cup of coffee, if we allow it to get dissolved by itself, it will take very long time. However, if we stir it, it will get dissolved very easily. So similar concept. If we increase the speed, definitely the rate of reaction will increase. So that's why the yield also getting increased when we increasing the speed. However, if we increase the speed above this 1250, there is no significant effect onto the yield. So that's why it was not studied beyond 1250. So it was actually tested, but it is not reported because there is no significant effect after 1250 RPM. And the last is effect of molar ratio of methanol to oil. And you can see the molar ratio, that is minimum value was selected, was 9:1, then 12:1, and 15:1. So it depends. This ratio is actually depends on the type of catalyst and the quality of catalyst. And as I told you, the stoichiometric ratio that is required is 3:1. However, we have selected 9:1, 12:1, and 15:1. Excuse me, a lecture. Okay, so that's why this optimized condition, this optimized value that we are getting over is here for the molar ratio of alcohol to oil is around 9:1. Because as we go on increasing the molar ratio from 9:1 to 12:1, what happens? when we go on increasing the temperature, molar ratio from 9 is to 1 to 12 is to 1 and 15 is to 1, there becomes a complexity in the separation of this biodiesel and glycerol. And due to that, the yield of biodiesel actually gets decreased. So that's why here we can see the trend that biodiesel yield is actually slightly getting decreased with increasing methanol to oil ratio here. And however, it is more or less constant when it is 15 is to 1. So that's why it is said that the maximum or the optimized value for the methanol to oil ratio is taken as 9 is to 1. That is the minimal value. Okay. So, after production of this fatty acid methyl ester, or I can say rubber seed oil methyl ester, this needs to be tested, and we generally do the characterization in order to understand the fatty acid profile or ester profile by means of GC, that is gas chromatography, or GCMS, that is gas chromatography MS analysis, and that is gas chromatography mass spectroscopy analysis. So we generally do that, and after that we also do the testing, various testing by means of or by following the standard methods which are given by ASTM. Okay. So what are the properties that that needs to be calculated? That is specific gravity, flash point, acid value, cloud point, pore point, kinematic viscosity. So I hope I don't have to explain each property, because it is pretty evident that, because as everyone is dealing with this energy and all, so it is pretty clear to everyone that what is the significance of each and every property. So just I'm telling you this, these are the limits of this ASTM limits, and whatever the product that we have produced, it is quite under the limits whatever specified by the STM, and it is also comparable with the diesel. So although the viscosity of diesel is quite less, that is 2.6, but the measure value that we are getting is around 4.91, and but the limit is around 1.926, so it is under the limit, so it can be used as a fuel very efficiently. Okay, so these are the some properties, and in the finally, if I have to summarize this, I would say this biodiesel is a clean, renewable, and eco-friendly fuel that can be produced from any oil or animal fats. If this biodiesel production can be commissioned, and if the farmers, like in the villages, if they encourage to take crops or the energy crops in their fields, then this biodiesel production can provide a huge rural employment and can transform rural economy very efficiently. And that particular energy plant can be used for mitigating the energy demand which is there from the villages or village sector. The dominant factor in biodiesel production is the feedstock cost. So definitely the processes or the research should be intensified, so that we can able to convert this cheaper feedstock, this lower quality feedstock into biodiesel. And a very important thing is that in order to get the biodiesel at the minimal cost, we need to do the optimization of the entire process, so that we can give, or we can give lesser amount of resources, and we can produce maximum amount of biodiesel. So in order to meet the energy demand, this small and medium scale plant should be commissioned at village level, so that it can give employments to the rural people, as well as it can able to help, or it can able to boost the rural economy, and definitely then it will going to help in boosting the economy of our entire country. So that is what from my side. So I will definitely encourage people to focus on the utilization of the biofuels like biodiesel, biogas, bioethanol as a fuel, and there is no need of hesitating that whether we should use it or not, because in recently in March 20 February or March 2020, there was one flight which took off from Dehradun to Delhi, and which was completely run on the on this aviation that is biofuel, which was actually produced from some vegetable resource. Okay, so there is no hesitation in utilization, because many people thinks that utilization of such fuel will going to hamper their engines and all, but it is not the case. And we should, as a people who are working in the area of renewable energy and the energy sector, we should encourage the people to uh, utilize this kind of a fuel, so that it will not only help in boosting the economy, it will also help in giving a very cleaner environment as compared to the environment that we are getting due to the combustion of the fossil fuels. So thank you very much. That is what from my side. And if you have any question, any queries, you can put forward.
Thank you so much, sir, for your informative guidance and presentation. There are few questions from students and faculties. So first question is biodiesel used as a pure fuel or is it blend with petroleum diesel?
Whatever the existing engine that we are having, we can use it directly also, like B100 fuel, and we can use it in a blade. So what is the main concept is that our main purpose is to minimize the consumption of conventional fossil fuel. So if we blend it with the conventional fossil fuel, definitely it will going to give higher efficiency as compared to the pure biodiesel, because pure biodiesel, it's containing a lot of oxygen in it, and definitely the complete combustion is possible by means of pure biodiesel. But the problem is the energy that is getting generated from the biodiesel as compared to the conventional diesel is definitely lesser. Okay, so that's why that area needs to be focused on. But if our purpose is to minimize the consumption of a conventional fuel, better to go for blending as compared to the proper means pure fuel. That is what my suggestion is.
Okay. Second question is there any need to provide special storage facilities for biodiesel?
Yeah, definitely. The major problem for the biodiesel is the storage, because when we keep biodiesel for a longer period of time, in the biodiesel it contains some unsaturated compounds, and due to that, when it gets exposed to the air, what happens? It attacks the air, and sorry, that it gets oxidized. So due to the oxidation problem, there are some additives needs to be added into the when we are storing this particular biodiesel. Some additives needs to be added so that it should not get affected while getting exposed to the air. So some additives needs to be added while it's storage. Yeah.
Okay. Then third question is how do biodiesel emissions compare to petroleum diesel?
Yeah, definitely. So the question that in the initial slides that I discussed, the means see there are three factors. If you see the conventional fuels, okay, in the conventional fuels, the problem is sulfur. So when the sulfur is there, uh, when we do the combustion of conventional fuels, it sulfur produces sulfur dioxide. Okay, so we are having a lot of sulfur dioxide into the environment, and due to this acid rain and is all happening. Okay, however, if you compare the combustion of our biodiesel, it do not contain any sulfur, so it is a zero sulfur fuel. So definitely the emission of sulfur dioxide is actually eliminated. So SOx elimination is zero. Okay, NOx, definitely it is there, but it is comparable with the conventional diesel. However, the question about CO and CO2, as it was I already explained that whatever amount of CO2 is actually getting combusted, it is getting emitted due to the combustion of this biodiesel. It is again absorbed by the plants that we are growing for the generation of feedstock. So that is how it is getting actually. If you see the net effect of the carbon dioxide, it is getting nullified, and the carbon monoxide, definitely carbon monoxide emission is far lesser as compared to the conventional diesel, because when we see the ester molecule, it contains oxygen in it. So whenever the oxygen is present in the molecule, it helps in complete combustion. So why carbon monoxide gets produced? Because there is incomplete combustion. But if there is a sufficient amount of oxygen or air is available, the complete combustion happens. So that's why carbon monoxide generation is generally not happens when we do the combustion of a biodiesel. So that's why if we see the environmental impacts and emission parameters of biodiesel is always greener as compared to the conventional diesel.
Okay. Then last question is why is biofuel not commonly used?
See, there are various factors. Means it is commonly used. You people are using, we are using, but we are not aware of that. Okay, so we are using actually whatever the fuel that we are seeing now in the market. Industries are blending that particular fuel with the biofuels. Okay, it is not like that. It is a completely fossil fuels. They are blending to some extent. So it is not like that. But the major problems that are available. If I specifically talk about the biodiesel, see, we generally say that the biodiesel can be used as an alternative fuel to the diesel. But if you see the combustion of the consumption pattern of the diesel, it is very high. Consumption is very high, and we cannot have that much amount of resources or feedstock available, which can be converted to the biodiesel, and that biodiesel can replace this biofuel or this conventional diesel completely. So that is the main problem. So initially the problem was cost. Now cost is comparable, but now the major problem is the feedstock availability. So we do not have sufficient amount of feedstock. So that's why we are trying to gather feedstock from all the resources that we are having, like waste cooking oil. Industries are trying to collect that from restaurants, hotels, and we are trying to focus. We are trying to get that feel that yes. But I can say that around after 10 to 20 years, definitely the biodiesel will be must fuel. Okay.
Okay. Thank you so much, sir. It's my honor to propose a vote of thanks for today's session. I would like to thank our guest speaker, Dr. Sumit Dhavne, sir, for informative and knowledgeable presentation for students and faculties. At the last, I would like to thank all the students and faculty members who are present for the today's guest lecture. Thank you, one and all. By permission of Principal
Uh,
Sir Dr. H.V. Deshmukh sir, I will declare that here today's session is end. Thank you so much.
Before that, I want to make one announcement. Please give me 2 minutes.
Okay.
Actually, those who are actually interested in understanding the renewable energy and what are the the future in the renewable energy and what are the different research is going on in the renewable energy, we are conducting one workshop on the recent trends in clean energy recently in March, in the coming March. So I will share that brochure with Professor Gavande, and I request you to please circulate to each and every department of your institute for the so that if people are interested in joining that particular workshop, it will be very beneficial for everyone, because you will get an exposure to hear from very international speaker, as well as the certification and all will be provided. Okay, so I will share that. I request you, Professor Gavande, please circulate to your institute. Thank you.
Okay, sir. Yes, I will definitely share it. Thank you so much. Thank you, all of you. Shall we stop, sir?